We are reviewing practice midterm exam problems 1 to 7.
All right, so let's get started. Okay, so looking at problem number 1, a new sidewalk will be 6 feet wide, 275 feet long, and filled to a depth of 3 inches with concrete. How many cubic yards of concrete are needed? There are a few things to note with this problem. We are asked for cubic yards. So cubic yards are the set of units that we want to solve for. And we know that this is volume, so we are asked to identify how many cubic yards of concrete are needed. We know that the new sidewalk will be 6 feet wide, so this can be designated as a width. 275 feet long, this can be designated as a length, and filled to a depth of 3 inches. We want to solve for the volume, and for the volume, you can multiply length times width times depth. And for reference, this is part of Unit 2A. Example number 7 on page 77 is a very similar problem that you can follow along with and practice with as well. So here we have volume equals length times width times depth. And notice that it is very important to identify the units. So the units for width and length are both in feet, and the depth is in inches. So to keep everything in feet for now, I will want to convert the depth of 3 inches to feet. All right, so the length here we have 275 feet. Width we have 6 feet. And the depth of 3 inches we'll want to multiply by a conversion factor of 1 foot over 12 inches. Will give us feet, right? So inches and inches will cancel out, and we'll be left with feet as the unit of measurement for depth. And so using your calculator, you'll see that you get 4,950 feet cubed over 12, which equals 412.5 feet cubed. Okay? However, we cannot stop there. We have to convert the volume to cubic yards, because that's what is originally asked for in the problem. How many cubic yards of concrete are needed? So to convert cubic feet to cubic yards, we will multiply 412.5 feet cubed by the conversion factor for feet to yards, which is 1 yard over 3 feet. However, because we're looking for cubic feet to cubic yard, we need to remember to cube the numerator and denominator of the conversion factor in order to get cubic yards. So from here, we'll get 412.5 cubic feet times 1 cubic yard over 27 cubic feet. Okay? And then from here, the volume in cubic yards is approximately 15.28. Okay? So that's how you would go about solving this kind of problem. And again, this is from Unit 2A. You can refer to example number 7 on page 77 of the textbook. The next problem states to use the following table of exchange rates to solve the problem below. So we have a table with currency, dollars per foreign, and foreign per dollar. And the different types of currency are as follows. So we are asked, how many Mexican pesos can you buy for $150? So we want to look at the line for Mexican peso. Okay? Okay, so this is all that matters to us for this particular problem. And from here, we're asked, how many Mexican pesos can you buy for $150? So we're going to multiply $150 by the exchange rate of foreign per dollar, right here, foreign per dollar, 12.73 pesos to $1. So 12.73 peso per dollar, right? Foreign per dollar. So the dollar signs will cancel out, and we are left with 1,909.5 pesos. So that's how many Mexican pesos you can buy for $150. Okay, so next we have problem number 3. Measurements are made at 2 different times. Find the absolute change, then find the relative change in terms of a percentage. Round answers to the nearest tenth if necessary. So in the last election in a certain city, the percentage of eligible voters who voted in a local election was 65.1%. This year, the percentage fell to 54.4%. So to find the absolute change, we should know that it is the new value minus the reference value, right? So it measures the actual increase or decrease from the reference value to the new value. So for this particular problem, the new value is 54.4%, right? It says this year, the percentage fell to 54.4%. So it is 54.4. The reference value is 65.1. And you'll get negative 10.7 percentage points. So always note that the absolute change units will be measured as percentage points. And with that being said, the relative change is always measured as a percent. Okay, so for relative change, we have a different formula. We have new value minus the reference value over reference value times 100%. Okay? So from here we can substitute what we know. And again, the new value is 54.4, and we subtract that by the reference value of 65.1. Divide that over 65.1, the reference value, and multiply that by 100%. And we get a relative change of negative 16.4%. Okay, so the relative change is the size of absolute change in comparison to the reference value. Okay, and this problem is very similar to Unit 3A. Example 1 on page 122. And just for reference for the last problem, this is from Unit 3A, and you can refer to example problem 15 on page 85. Okay? All right, so for problem number 4, we're told to solve the problem. The percentage of registered voters who voted in this election was 45%, up 18% from the last election. What was the percentage that voted at the last election? Okay, so this problem is very similar to example 11 on pages 128 to 129, just for reference. And here, we want to solve a percentage problem. So we know that the percentage of registered voters who voted in this election was 45%, right? So this value here voted this election. And it's up 18% from the last election. So that indicates the relative change from last election to new election. Okay? So we are going to want to solve for the previous rate, right? Because it's asking us what was the percentage that voted at the last election. So that indicates that we want to know the previous rate. Well, similar to problem number 11 from the textbook, we have new rate equals a sum of 100 plus 18% multiplied by the previous rate. And what we've done is added 18% because it says that it's up 18% from the last election. So we know that that's the relative change from the last election to the new election. So we can add it to 100%. And so we get that the new rate is equal to 118% times the previous rate. And to solve for the previous rate, we can divide by 118% on both sides. So 118% on the right-hand side will cancel out, and we are left with previous rate equals new rate over 118%. Okay? And I'm going to change the percentage to a decimal. So 118% is equivalent to 1.18. And we actually know the new rate. The new rate is 45% from this current election. Right? So we have 45% divided by 1.18. And so we get 38.13%. So that is the amount of voters that voted at the last election. Okay? And again, this is very similar to example number 11, pages 128 to 129 of the textbook. And this is Unit 3A. And I just want to note that the reason why I changed 118% to a decimal was to keep the numerator, the new rate, as a percentage. And so our units would end up being percentage. So moving on to number 5, in 2010, a company increased its workforce by 25%. In 2013, it decreased its workforce by 20%. How does the size of its workforce at the end of 2013 compare with the size of the original workforce at the beginning of 2010? So this problem is a little tricky, but for reference, this is actually from the textbook. So let me show you. this is taken from Unit 3A, and this is under the section Abuses of Percentages. And we're shifting reference values. This is on page 129. Okay, so to start, we can evaluate this problem by assigning an arbitrary number for the original workforce. So let's use 100 as the original workforce. And remember, you can assign any arbitrary number. And so in 2010, so since our original workforce is 100, in 2010, we are told that a company increased its workforce by 25%. So we can add 25%, and we multiply this by 100. So we have 100 plus 25% of 100, right? So that's 100 plus 25, and we get a sum of 125 workers. Okay, so that is the number of workers in 2010. In 2013, however, we're told that it decreased its workforce by 20%, so decrease by 20%. So from 2010, we know that the workforce is at 125. It decreased by 20%, so we subtract by 20%, and we can multiply that by the number of current workers at 125. So we'll get 125 minus 25, and we get 100 workers at the end of 2013. And so if we go back to the original question, we can note that it's asking us how the size of its workforce at the end of 2013 compares to the size of the original workforce beginning at the beginning, or at the beginning of 2010. So at the beginning of 2010, we said that the original workforce was 100. And please note that this amount of 125 workers is the amount of workers at the end of 2010. So, but at the beginning it was 100. And so in that case, in 2013, since we're ending with 100 workers, it's the same workforce. So there has been no change. Okay, so same workforce. Okay, so moving along to problem 6, we're told to solve the problem. And suppose the current cost of gasoline is $3.21 per gallon. Find the current price index using the 1995 price as the reference value. So in 1995, we're told that the cost of gasoline was 120.5 cents per gallon. Okay, so we know that this is the Consumer Price Index for 1995. And we want to find the current price index. So again, this is, for reference, this is very similar to example number 1 on page 163. So this is unit 3C. Okay. And for this problem, we can use the formula for index number. Which is value over reference value times 100. So that's the formula for index number. But in relation to our particular problem, we'll want to evaluate it as so. So our value would be the current price. The reference value will be the 1995 price multiplied by 100. So with that being said, the current price is $3.21 per gallon, as mentioned in the first sentence. Divided by the 1995 price of 120.5 cents per gallon. But since 120.5 cents is in cents, and I want to change it to dollar, to the unit of dollars, we know that there are 100 cents in $1, right? So it will become $1, and we have 205 cents. And I'm leaving the thousands place. So we have the tenths, hundredths, thousands place for more accuracy when you enter it into the calculator. Okay, so the current price index will be 266.4. So that's the current price index using the 1995 price as the reference value. Okay, so lastly, we're going to wrap up this online session with problem 7. We're also told to use the Consumer Price Index, but here we have a table of the average annual Consumer Price Index from 1982, from 1986, to 2012. And again, just to reinstate, the Consumer Price Index is not going to have any units because, as we saw in problem 6, the dollar signs of the numerator and denominator will cancel out, and so you're left with a numeral with no units. Okay, so between 1990 and 2000, a college raised its annual tuition fees from $4,450 to $6,710. We're told to find the relative change in the fees over that period and compare it to the overall rate of inflation as measured by the CPI. So were the tuition increases in line with inflation? Okay, so this is a two-part problem. We're looking at 1990 and 2000. So it's important to correctly identify the correct consumer price indexes for the following years. So we have 1990 with a CPI of 130.7, and in 2000 we have a CPI of 172.2. And we know that the tuition fees, increased from 4,450 to 6,710. So first we want to find the relative change. And for reference, this is from Unit 3D. And this is similar to example number 5 of the textbook on page 166. And this is inflation rate. So with relative change, we can use the formula of compared value minus the reference value divided by the reference value. And I'm running out of room on the screen, so I'm going to try to make this smaller. Okay, there we go. And this is multiplied by 100%. So that's our formula for relative change. So for relative change, we can substitute the values that we know. So the compared value is going to be the new value from the year 2000. So that's 6,710, and we're going to subtract that by our reference value of 4,450. And we divide that by our reference value again of 4,450, and we multiply it by 100%. So after you plug this into your calculator, you'll get 50.8%. So this is your relative change at 50.8%. And again, because I'm running out of room, I'm going to make this smaller so we can solve for the overall rate of inflation. Okay, so the overall rate of inflation from 1990 to 2000 is a different formula. And remember, this can all be found on page 166 of your textbook. So it's the current price index or the consumer price index of year 2000 subtracted by the current price index of 1990 over the consumer price index of 1990 multiplied by 100%. Okay. And just trying to move this over. There we go. Okay, so we can substitute the values that we know. So the consumer price index in 2000 is 172.2. Again, I'm getting this from the table. We can see that the consumer price index in 2000 is 172.2. And we can subtract that by the consumer price index from 1990 at 130.7. And divide that by the consumer price index of 1990, which is also 130.7. It's the same number. Multiply by 100%. And we get an overall rate of inflation at 31.8%. But we're not done. Sorry, earlier I misspoke. I said that this was a two-part problem, but this is actually a three-part problem because not only are we asked to solve for the relative change and the overall rate of inflation, but we are also asked if the tuition increases were in line with inflation. So the tuition increases have a relative change of 50.8%, which is greater than the overall rate of inflation at 31.8%. So our overall answer is, let me type this out for you guys in a different color. Okay, well, I can't seem to change the color, but no, the tuition increase was greater than the rate of inflation. And so that is how you would answer this question in its entirety. So you're not going to get full credit unless you complete the entire problem. Just make sure to go back to the original problem and make sure that you answered everything. So we found the relative change, we found the overall rate of inflation, and we answered the third question. Okay?